Okay, so today we're going to be having a webinar on why smart water projects go wrong and foundations for digital transformation with great speakers, Dr. Peter Prevos, Anna Carpenter, and Tyron Ware. So very excited to have this going with SWAN. We are now looking into adaptive data management group, which is more going into inclusive and how can we go back to the foundations of smart water. So this is our first Asia Pacific focused webinar on our adaptive data management group. So before I get started, for those who are maybe less familiar with SWAN, I'll give a bit of a background here. So that's going to be my SWAN update and the presentations by our three amazing speakers. And we're going to be having a time for Q&A and some open discussion afterwards if you have any questions to them. So for those who might be not familiar, SWAN is a global nonprofit forum that brings together water utilities and solution providers and industry experts to advance the use of smart water and the digital data driven solutions for drinking water, wastewater, and stormwater utilities as they move across their digital journeys, and we provide different resources and knowledge series and the global sector information. So these resources are primarily driven by our diverse ecosystem of members who use this unbiased platform to collaboratively unlock the value of adapting data-driven solutions. So you can see people across utilities, that those we have in the call right now, and solution providers and industry experts and young professionals. So it's a pretty wide group that we have here. And these are some of the examples of our recent practical reports and tools our members have created to guide the sector in the smart water. And some of the guides are on climate resilience, IT/OT operation that you can see, and adaptive data management is going back to like cybersecurity and data foundations and making the business case. And also another recent one coming up is on smart metering. That's a more broad one also coming up with us. And SWAN is also all about our engagement across our members. So this is one of our event highlight from last November that we had host our Asia Pacific workshop in Sydney. Had a really good time looking into kind of policy and technology of smart water. Some of you might have been at the event. And we have other exciting things that are coming up in April in Asia Pacific. We have a partner event at the Asia Water in Malaysia is coming up. We're hosting a SWAN workshop of a half-day workshop as we are a digital lead partner there. And we are currently looking for partners and utilities who are coming to this event. If you have any case studies, please reach out to me. I'll be happy to work with you if there's an opportunity to feature you or have your team there. So please let me know. And also our annual conference is coming up. So every year we host an annual conference, and this year it's going to be between June 2nd to 4th in the US. So currently we are accepting call for abstracts. So if there's any case studies and journeys of your smart water that you would like to share with us, please go ahead and do that. And we have, I think, more than a week that our call for abstracts will be ending. So we would love to hear from you. And this is a resource that you can see if you're writing your own abstracts. And we also have an online event to engage and share this knowledge with everyone. So the upcoming, some of the virtual webinars here are you can see majority of these are members only, but we have also another open access webinar coming up, which is primarily looking into beyond the smart metering. So that you might be interested in, go to our website and have a look at it. So that's how our upcoming events are looking at right now. And before I give it over to Peter, I wanted to pause a question to you guys. So throughout the webinar today, we will be using engagement tool called Mentimeter. I would like you guys have your phone ready or your laptop ready to answer some of these questions. I have one question for you all. If you have your computer, let me just share it with you here. Yep. If you have your phone with you, you can just use this QR code. But if you're on your laptop, you can just go to what I sent you on the chat here. Go to the link, and you'll be able to answer this question. You'll see this on your computer or mobile phone. So we wanted to ask you, what is your organization's top smart water priorities for 2026? Just really good to see some of the answers on data management, GIS, asset and data validation, customers in their journeys. Yes, customer experience, use of AI. I think we're getting a lot of response. Reducing non-revenue water, using digital tools. Yes, we have a lot of resource on that. Piloting emerging technologies, digital transformation of our sewer network, non-revenue water, to raise awareness of wise technology within Australian water utility, smart water monitoring solutions, advanced metering infrastructure, reduce non-revenue water reduction, use of AI in customer use cases, AI for energy optimization. We do have also energy efficiency and smart metering community of practice groups that you might be interested in looking into, adopting industry standards. Yeah, these looks really great. Thank you so much for all sharing it. We're going to be asking a couple of questions throughout our presentation, but I would like to give the floor to Peter shortly. Just a quick one that throughout the presentation, we will be sharing our screen, but I will be sharing this recording and also our presentations at the end of our workshop. I'll be sending an email to everyone, but we will be, if you have any Q&A, if there's any questions, you can put it in the chat throughout the conversation, and we will be answering it at the end of the presentation. So without further ado, I wanted to invite Peter Prevos, who is the manager of data science at the Coliban Water, to share about why smart water projects fail. I think, Peter, you are on mute. Peter, do you want to unmute? Oh, there you go. We can hear you
now. Sorry about that. Yeah. Okay, we're back in. So yeah, thanks everybody for joining, and thanks for inviting me. I'm going to talk about a little bit about building foundations for digital transformation. So I'm going to be looking at the basic principle of implementing smart water, based on it from a data science lens, and the conditions for successful implementation. But on the reverse side, where things can go wrong. So to introduce myself, I'm Peter Prevos. In my day job, I manage the data science team at Coliban Water. We are a water utility in regional Victoria in Bendigo, just north of Melbourne. But I'm also a senior adjunct lecturer here at the local university, La Trobe University, where I'm supervising a PhD student looking at some smart water solutions, and more about that a bit later. A little bit about my career. That I've been analyzing data for more than 30 years. So this thing, data science, is not really new, but a lot of things have happened in the last 10, 15 years that really put data at the forefront. So I started my career just with pen and pencil, and then started actually writing code using spreadsheets. And when I started doing my dissertation, I quickly realized that spreadsheets are no longer the solution. And I learned myself how to do data science code and rolled into this corporate job. My background is I'm a water engineer, so that's where I come from. So I understand exactly where water utility is coming from, but my focus now is to analyze data. And we analyze data from operations, customers, financial data, anything that that we can help our colleagues with. So let's look at this principle of smart water and some of these elements here. This is a model developed by SWAN that I'd like to introduce, and I'll touch on each of those in this presentation on their importance. So what is this thing called smart water, right? Water can be smart. And also some people talk about digital disruption in water. Well, technically water can be digitally disrupted because we're always a physical service. But the technologies that now are available to us, we can optimize and we can improve those physical services. So smart water is a fully integrated set of data-driven components and solutions, which allows us to optimize how we work as a utility. And the smart water journey that was developed by SWAN, which is available on their website, talks about these 6 layers, where we start with physical assets, right? We always have a physical reality that we need to deal with, and that becomes more important later on in the talk. Then we have our sensing and control layer. So we need to measure what happens in that reality. So think about SCADA and your asset system, but also the people in the contact center that take the calls from customers and actually hearing what customers are thinking about our services and what they are experiencing, what our regulators are telling us, data from external sources. So there's a lot of information coming in to a water utility. And then we collect and communicate that information. This is becoming more and more important with having so many data sources. It's really important to have a good integration platform that allows you to put all that data together. Then once you have all that data, you need to be able to display it somewhere, manage somewhere. Then we analyze it. But what's extremely important, and that's number 6, and I probably should have started with 0, is that you need to have a strategic outcome. We need to have a strategic driver. And what I'll emphasize later in the talk is the importance of starting with an objective rather than starting with a technology. So the idea of smart water is encompasses all these different things. So we talk about the physical assets, we talk about how we measure things, how we store the data, how we display the data, but also how can we strategically embed this within our organizations. So for those of you who are new to this topic, some examples, we can forecast customer and network leaks, or we can detect them very quickly. Predictive maintenance is an often used tool. Intelligent alarm management. We all know the problem of control rooms and operators being flooded with alarms. Well, with some smarts, we can help reduce that cognitive load on our operators. We can analyze the sentiment of customers based on the things that they are telling us. I'm doing a very interesting job now where I'm analyzing transcripts of 100,000 customer phone calls to see if we can find any information in that using some machine learning. And this is the true voice of the customer. And without data science tools, that would be an impossible task, right? We automate fully our regulatory reporting, so it's just a standard process. Image classification instead of sewer camera inspections, etc., etc. There's so many things that can be done with data science. And you've probably seen a version of this diagram before, and this is I use this to illustrate a few important points. Normally, people talk about data, information, knowledge, and then maybe in the top they even have wisdom. But I created a different version of this in that I put the reality at the bottom. Quite often, it's forgotten in a data science context that there is actually a reality that underpins the data that we're analyzing. And I believe very strongly that it's important that when you do have a smart water project, that you always bring it back to that reality. So within my team, for example, we have undertaken a few what I like to call data excursions, where we take the team and, for example, we took a trip to our reservoirs. We spoke to the reservoir keeper about what are your data needs, what are your day-to-day problems. And from that, we were able to say, hey, we can help you with this. And it really helped my team to really understand what is this abstract stuff that you see on your computer screen? What does it actually mean? And I spoke about the different layers that are also in the SWAN model, which come back here as well. But what's really important is that once we collect the data and we analyze it and create a report, and then we create an insight by sharing that information, is that there has to be a feedback loop back to the reality. This is what people talk about when I say actionable intelligence, right? We want to create a report when somebody looks at it, that they are either confident that everything is fine or they know what action to take. That is for me, the ideal report. And what that points to, two important things: that understand the reality of what you're analyzing, but also have an objective in mind when you do this. What has changed from sort of during my career when it comes to data is that the reality is still the same, right? A water utility really hasn't changed that much for the past decades, 100 years perhaps, where we take water from the environment, we treat it for consumption, and then we pump it to customers. That reality layer hasn't really changed. But what has changed dramatically is that it is now much cheaper to collect and store data. Every system that we use, like our customer system, our asset management system, our internal processes with SCADA system, laboratory, they all leave a digital footprint, and often that data goes unused. So we now have a lot more data available. But also when it comes to analyzing and reporting, the computing power that we now have available compared to when I started my career is exponentially grown every year. So we have a lot more computing power available. And also, what a lot of people forget is that the vast majority of data science algorithms that are out there, they are open source. So this is a massive global collaboration project where innovation really goes much faster when people start sharing their interest. Now, just as a little bit of a joke, but also an important aside, this is a slightly different version of this pyramid. So when we collect data, it is unstructured, right? And then we turn that into information by adding some structure. Then we're looking for patterns and create knowledge and maybe insights. But things go horribly wrong, and that's the last slide here. And we see that too more often than not when people start drawing their own patterns and looking at it and thinking, oh, I can see a pattern. Because the human brain is a pattern recognition machine. We are just programmed, our minds are programmed to do that. And this is the importance of having really good statistical knowledge, is that it helps you to not do that, to analyze your data in a scientific way. So that's one reason I really like this diagram. Although it's a bit of a joke, there's a serious message to it. So what is this thing, data science? A lot of people have different definitions of it. For me, it's the systematic collection, storage, transformation, analysis, and presentation of data to meet business objectives. We're not doing this for fun. We're trying to create some real benefits. And the term didn't exist until I think it was about 2010 or 11 or 12. And in 2012, in Harvard Business Review, an article appeared where it says, "Data scientist, the sexiest job of the 21st century." And I thought to myself, hey, I like analyzing data. I want that job title. So that's how I managed to convince the business that they need a data science function. But I already spoke why it's different, and this diagram sort of shows that a little bit. It was developed by another data scientist called Drew Conway, and he says to be a data scientist, you need to have domain knowledge. So in other words, you need to understand what a water utility does. You need to understand this reality layer that I spoke about. You need to understand mathematics or statistics and then computer science. Now, domain knowledge in mathematics, this is traditional research. Most water professionals have that knowledge. But the computer science is the new skill. So I retrained myself to learn about computer science, and that's how I became a data scientist. And within that, people say, well, if you have all these three skills, you are a data science unicorn. I have a training program, which I call the Data Science Unicorn Breeding Program, where I teach water professionals computer science, so to help them better analyze data. This is all good and well, right? This is all very optimistic, and people have a lot of expectations, but there are some dark clouds on the horizon. Eric Siegel, he is an author who writes a lot about data science and machine learning and artificial intelligence. And he did a survey and found that 80% of machine learning projects are not deployed to production. They finish up in a PowerPoint presentation and never go anywhere else. So what that means is that data scientists, they do all this work, they create a fantastic predictive model or classify or whatever it is that they do. It gets presented to management or the executive, and everybody goes, oh, that's interesting, and it doesn't go anywhere. 80% of machine learning projects are not deployed in production. That is a massive, massive number. And then more recently, MIT, so the Massachusetts Institute of Technology, did a bit of research, and they found that 95% of generative AI projects don't proceed past the, and there should be trial stage at the end of this line. So that's also not a very good picture, really. And to illustrate that, this curve here on the screen, it's the Gartner hype cycle, which is a curve, not a cycle, but let's not dwell on that. And Gartner is a research company consultancy that publishes each year. And this is the most recent one about AI. And for example, oops, go too fast. We see here that generative AI is now on the downward spiral. So how do you read this graph? Technology is introduced to the market, is an innovation trigger. Everybody gets really excited about it. Remember, a couple of years ago, everybody thought that generative AI was going to change the world. But then it enters into what they call the trough of disillusionment. Sounds a bit like a Tolkien novel, but yeah. So anyway, the enthusiasm wanes, and a lot of the technologies even disappear into the abyss. And then there's the slope of enlightenment, which for some technologies come back and then reach the plateau of productivity. And it's really all AI, also all advanced technologies seem to be going through this cycle. Some technologies disappear, some of them actually reach the plateau of productivity. Remember, a few years ago, everybody was talking about blockchains, right? And all of a sudden, that has pretty much vanished. So there's a problem in that, and I started thinking about that. Why is this problem? What's actually going on in the industry? And I believe there are 4 main causes, and I'll quickly go through those 4 causes. I don't have time to explain those in detail. That I believe are the root causes of failure, but also the foundation of success for a good data science product. Low data literacy can be a problem, so that's actually understanding what data science is about. A lack of standardization. Data governance can be a problem, and the link to business outcome. So I'll go through those quickly, and we also have a little question for you to ask in a second. Data literacy is extremely important. But I'll explain to you first about data literacy, what that means, or what it encompasses, and then why is that important to successful implementation. Most water professionals, they go to university or have higher education, and they're pretty good at mathematics, and they understand how to read a graph. But as I just demonstrated to you, that what is now data science requires a lot higher competencies of our staff. It requires a lot higher competencies of ourselves. So it's an ability to ask real world questions from data sets. It's the ability to look at a problem, look at a data set, and then be able to work out how can I solve it at the high level. Ethical use of data as well, because once we start collecting data from customers, there's a whole lot of ethical responsibility. How to be able to select the right data, how to be able to clean data, how to analyze it, data storytelling, how to critique the outcomes and how to interpret the outcomes. It's a big ask here, and with another group, Intelligent Water Networks in Victoria, we are about to embark on a data literacy project to help the industry improve their skills. Now, data literacy is not only important for the analysts, for the data scientists, right? For the control room operators or whatever it might be. Data literacy is important at all levels of the organization. And I've got a random picture here that I plucked from the internet of somebody recording data on a clipboard. Well, that's where the data journey starts, right? Not everything is collected on SCADA. So what I believe is important, and even as a data entry person, you need to have some data skills, know what happens with the data, what good data quality means. You need to be able to interpret reports that are sent back to you. For example, somebody working in the contact center, we can, with some good data literacy, we can help them write better notes into the customer relationship system, right? So that we can use those texts to analyze it. There's an obvious task there for engineers and all that to be able to analyze data, but data governance is also of importance to board members, for example, the ability to critique some of the reports that they might get, and even customers. Customers, we are throwing lots of data at our customers, so also they need to improve their data literacy to really extract that value from the data. I'll go to this slide first and then we'll go to the Menti question, because here is the main difference between the past and the present. There's a difference between traditional analysis and contemporary analysis, let's say machine learning, and I'll explain that a little bit. Traditional analysis, what I was taught at university, and here's just an example, it's a pump curve, right? And most of you will know how to read that pump curve and be able to draw a conclusion from that. Traditional analysis is deterministic. We have a formula, we have inputs, and there's outputs. And if you use the formula correct, and if the inputs are the same, the outputs will also always be the same. With machine learning, it's very different. And this little diagram here is roughly how a neural network is put together, how all the neurons talk to each other, but it's just an illustration. Machine learning is stochastic. And so it means there's a sense of, there's some randomness in it, so the outcome is not always exactly the same. It is also a black box, because the machine learning algorithm actually creates the rules on the fly, while in traditional analysis, the formulas are given. And what is happening if you try to implement a fancy machine learning algorithm, sometimes that's hard for operators to accept because it's a black box, right? Nobody can look into it. It is very different to that traditional analysis. So let's do a little Menti question. Maybe Zolboo, you can take over the screen for a second. And to see, just be honest, where do you think you are rated in your data literacy? You know nothing about data at all, or you have some basic data literacy. If you're good with spreadsheets or use Power BI, it's advanced. If you understand machine learning and actually knows what happens in the black box, then you can rate yourself at full data literacy. Just to, we're not being scored on this, and it's all anonymous. So be good to see what the outcome is. Cool. This is yeah, it's almost a nice normal distribution. So that's a good sign. One person is being very honest. I like that. I like that. Cool. So I'll take out the screen, Zolboo. I lost. Oh, here we are. Okay. Now the second problem, I think, is a lack of standardization. So we have standards, civil standards. In Australia, we have the drinking water supply code and the sewer supply code. And the last time I looked at those, there's nothing in there but telemetry. We have IoT, Internet of Things, and it's very cheap now to collect data, but how many is enough? Should we carpet bomb our region with sensors, or is there somewhere in between way? And standardization is also about standardizing data flows. And there's some really good tools for that now. So standardization is important. And I'm not going to dwell on this too much. This data governance is important. As how much data do you want to collect? Who is responsible for the data quality? As you know, rubbish in is rubbish out. And data scientists can help with this. We can do some anomaly detection and say, hey, this data doesn't look right. But what about data retention and cybersecurity? We're doing some research now and comparing leak detection algorithms that are published in the literature, and most of those algorithms are actually tuned on fake data, on generated data. Now we are trialing those on real data, and we're finding some real problems. And I'll start. This is my last section. So the link to business outcomes is also very important. The problem is that we have so many solutions. We have more solutions than we have problems. There's so much technology available. So my best advice is always start with a problem. So start with the benefits that you want to achieve. Do you want to improve the effectiveness of a process? So for example, for digital meters, we decided that we want our digital metering to be more effective, to have less errors. Efficiency. Our digital metering reduces the need for physical meter reads and also gives us more data. And assurance is another benefit where we are able to communicate better to our customers and to our regulators about how awesome we are. But on the other side, there are costs. There's a monetary cost. Obviously, you have to pay for this stuff. But there's also a time cost. So that's it takes time to consume all these reports that people are creating. And the mental cost relates to the need for us to be more data savvy, to have more data literacy. So here is an example of somebody who looked at digital metering benefits and how much data you actually need to achieve those. So for example, if you want to look at how much water each dishwasher uses, you need every 10 seconds data. But if you want to do billing, you only need data every single day. So here's an example, and there's a link down in the description below where you can find this information about how you can decide to achieve a business outcome, how much data do you need to collect? And that's very important. So I'm going to wrap it up, not to take too much time for my next speakers. So the takeaway is that always start by defining your business objectives. Don't jump to a fancy technology because it happened to be out there, except maybe on a trial, but work through your business outcomes and then see what technology is available to solve that problem for you. And find the data solutions for these objectives. Train your team to increase their data literacy, not just the data science team, the whole business, and perhaps even outside your business as well. And use standard applications and integrations to make your life easy. There's a huge risk that we end up purchasing all these different tools that have very specialized tasks, but there's also some good generic tools out there to help you with that. And as a segue, the next presentation by our friends from Logan Water is a great example of an organization that has built this good foundation and used the really good foundation of knowing their business objectives, develop their analytical skills, and found some really great solutions to better operate their control room. So I'm really looking forward to the presentation. If you want to keep in touch with me, my website is lucidmanager.org, has a lot of content about data science. Ping me on LinkedIn. I'm also on some social media and a bit of a shameless book plug as well. But yeah, thanks for your time, and I look forward to the next presentation. Zolboo.
Thank you ever so much, Peter. Good morning from Queensland, Australia. We're just going to share our presentation.
And Tyron, would you like to ask a question at the beginning, or during would be good, about the control room before we kickstart?
Probably at the end. We'll go at the end if you don't mind, Zolboo.
Sounds good.
Any questions can go into the chat. We are seeing them up here on a large screen. Let us know when you're ready. Okay. Welcome to today's presentation from myself and Ty. Today what we're going to do is we're going to present our control room. We are based on level 2 York Street in Beenleigh. And for today, we're going to be talking about our control room, and we're also going to be going into how we extract data from some of our popular software systems. So first of all, I'd like to acknowledge our country. I acknowledge the Yugambeh people as the traditional custodians of the waterways and across the city of Logan. I pay my respects to elders, past, present and emerging, and recognise their enduring connection to land and water. As we come together today, we commit to caring for water, sanitisation and country, and to honouring those enduring relationships through the work we do in operations.
Hi, all. My name's Tyron. I have just over 18 years experience now within Logan Water and Logan City Council. So I started my journey back in 2007. I was a water labourer in the field crews, so fixing and repairing our Logan Water infrastructure. Moved up through over the years. I got myself into a role with scheduling and dispatch within our office here. From there, became a maintenance planner, and I am now a facilities and logistics lead. So I now look after our civil maintenance planners, our scheduling and dispatch, and also we have our current first responder team in the field. So all the decisions that we make, they're all data driven, and we really use our data to streamline and get some high performance out of our field staff and within our business.
I'm Anna Carpenter. I'm the Integrated Services Hub Lead. 12 years experience working in control rooms, a little bit of a different industry. I was in the military, 12 years in the British Royal Navy. So big, varied, a lot of experience in different type of control rooms. My passion grew for water 7 years ago when I first came to Australia. And ever since then, I've really grown into the water industry and how we can really improve with our communities here at Logan. We can go on to the next. We've got a short video for you guys to watch. So this is an overview of what our integrated service hub looks like. So yeah, it's just a couple of minutes, so please enjoy.
The way we work is changing. We are creating one connected, integrated Logan Water. And the right teams are in the right places to deliver our services with a consistent, modern experience workplaces, facilities and depots. Our new building, the York, provides an amazing opportunity to bring many of our people together across our existing sites. A key aspect of this will be our integrated, also known as the ISH, on level 2, that integrates and coordinates our service delivery. So what does a standard day in the ISH look like? Let's take a look. The working day starts with the daily stand-up. This conversation ensures that all program leaders have clarity on the plan and metrics for the day, yesterday's performance, and overnight changes. Risks are identified, monitored, and managed proactively throughout the day, with the daily plan changing as required. Team members will be able to monitor performance data and metrics through the SIS. This will allow us to keep track of our metrics, including network performance, plan and schedule delivery, customer service and safety outcomes in an integrated and holistic manner. With our move to planned maintenance, the ISH will be the centre of our scheduling and dispatch functions, where we will create daily and weekly work programs for our crews. These schedules will be shared with the supervision team at Smith Road to oversee and report back on works and progress throughout the day. Over lunch, the customer coordinator notices an increase in customer calls in one location within the city. The ISH lead, customer coordinator, network operations team and scheduler get together and use the SIS to display an overview of the customer inquiry's geographic location. The ISH team will monitor network performance and any planned works that may be contributing to the issue. Once the nature of the incident is triaged, the most suitable crew nearby the location can be tasked to provide immediate assistance. While the incident is unfolding, the customer coordinator is real-time monitoring social media feed activity and keeping the community up to date. Being both located in the same facility, the ISH lead and customer coordinator can ensure incidents are managed in a consistent and integrated manner. The management of Logan Water's wastewater treatment plants will occur from the ISH on a 24/7 basis. This will entail monitoring and configuration of the control systems, Cytect SCADA, that run each treatment plant, responding to alarms, and review of production such as solar energy and biochar. The ISH night shift will be responsible for monitoring the operation of all Logan Water assets, including network, treatment plants and facilities, and responding to any alarms or events that occur. The final hours of the night shift will involve reviewing any overnight issues and determining how to modify the planned schedule for the coming day. The Integrated Service Hub will enable a consistent approach to service delivery and support through end-to-end visibility of customer coordination, planning, scheduling and dispatch, networked operations, and SCADA operations and management. This connection will foster a greater focus on the end-to-end delivery of services and optimise delivery to customers and the Logan community.
Okay, so what is so different about the Integrated Services Hub? So my past history, usual control rooms are just for network controlling. One team, very isolated for concentration, looking at networks, making that a priority. However, the ISH, how we've modelled it is a little bit different. We've brought all the main stakeholders into one room. So it really makes it so easy to talk in between teams so we can get really good relevant information really, really quickly. We can get teams dispatched as quick as we can, and it's actually working really, really well.
So why an ISH and what's different from the past? So we use collaboration communication as our consistent theme. So we make so why the ISH is we make life better for our field crews. We focus on our customers, our growth, our collaboration with one another. We're efficient, we're aware, we have linkage between our stakeholders. We have a centralised view, so we're all looking at the same thing, we're all talking to each other at the same time. We have that end-to-end visibility. Our communication is no longer via emails and phone calls, Teams. We're sitting next to each other now, so that communication has elevated, and teamwork. So we're no longer just working in our silos. We're now as one. So what's different is that collaboration, our connection with one another, working together and sharing information. Probably a big key one that we have there is our SCADA team can see high water usage, which usually means that we've got like a broken water main, and we can communicate that in real time to our customer team so they can already start being prepared and ready for when our customers start calling through, or vice versa. If something hasn't come through SCADA, we can start letting them know that we've got an issue, what to start to look into. That also means that we can let our field crews know ahead of time what to expect as well. So that leads into our promptness, our proactiveness, our agility to move from planned maintenance to reactive maintenance very quickly. We've broken down those silos. Our workflows become a lot quicker. They used to be non-communicative, so that was because of that barrier through emails that, you know, somebody hasn't checked their email for a couple of hours, phone calls, people aren't answering. We've taken all that away, and our field interactions have changed to the need to understand this as well.
Okay, so the main stakeholders in the ISH, I won't go into each stakeholder, but it is made up of the customer advocacy team. They're the ones that are talking directly to the public about any events that are happening, whether it be a water main burst, whether it be low pressure, and whether it be an environmental issue of wastewater impacting the environment. Schedule and dispatch, these are the ones that are talking to the field crews at all times. We have a great big mapping system visible in the ISH where we can see who the closest crew is and who the most capable crew is. Then that takes us over to network control. These are the guys that are looking at SCADA 24 hours a day. They are on a rotating roster, and we are now noticing bursts, large leaks, before they're actually getting called in by the public. So it's one thing that we're really, really proud of. We're actually noticing it before the public call it in. IOP team, these are the teams that are actually, they come up with plans that reduce customer impact. They provide in-depth plans of how contractors, civil maintenance crews, and our partnership can isolate mains safely and really have minimal customer impact. Then onto our last section would be the maintenance planning. Maintenance planners make sure that all our complex jobs that need extra resources, so whether it be Energex, pole grabs, whether it be traffic control, vacuum excavators, if it's going to be a large customer impact, the maintenance planning team really give good, safe plans into how our field crews can get really good outputs in the field. And in my role, so what I do in the ish is I oversee. I like to think myself as the umbrella. I like to see the work processes that I've created go from one team to another to another. It can get busy. There's sometimes a lot of adrenaline running through that room. My passion is to keep it really nice and calm. Everybody in that room knows exactly what they're doing, and I'm really proud of them all.
So what does it mean to be teams? So think of the ish team culture across Logan Water as a cultural theme. We're all leaders in development of the ish team and the way it works. So even for those who are providing interim support, become advocates and educators for all things that happen in the ish. So our leadership team, they lead all levels. They build the environment, they build the culture, they build the trust, the growth, and they support everybody else around them. Our end-to-end business, we know what contributes from one end to another, so start to finish. So from a customer call all the way to that job being completed in the field, all the way up to our finance team. So we've got an eye on that end-to-end business. And our planned and deliberate, we know what we need to do to be successful, and we know the decisions that we need to take. And what we've been doing with the Smart Water is using our data that we now have to drive those decisions.
So SCADA is one of our main pieces of software that we actually use in the ish. That's what we use to actually look after all of our assets in our networks. I will quickly go through them. We have 144 sewer pump stations, 9 water supply facilities, 6 dosing facilities, 126 CP loggers, 149 DMAs and PMAs, 29 water pump stations, and 3 SEQ water offtakes.
Some of the software that we use within the ish to make this this effective. So we use Genesis for our phone calls. We use Trello for our isolations team. We have Mex, which does a lot of our treatment. Our GIS, which we use for our mapping. Our Tech One is our work order and our asset database. Our SCADA, which is our alarm system. Takadu, that is our leaks monitor. We also have Teletrack, so we know where our crews are at all time, and we also use the Microsoft Office tools as well to help us through. We use Planner a lot in Microsoft Office.
I'll let you do the next few, Ty. This is for you. This is your baby.
So some of the way that we use Tech One and now data analytics to really drive us forward, probably our four top ones that we use is our priority works, the size of the elephant, desired service of leaks, and our Logan City councillors. I'll take you through a couple of these and what they mean. So our priority works dashboard. So this is using Tech One data. We had to standardize a lot of our data to make these dashboards work. So that was a big obstacle to overcome. Once we started cleaning it up and using the same sort of language, we were able to actually get a hold of what's ahead of us. This one also lets us know what's coming in in live time. So this is on one of our screens within the ish. So when for example, a priority one comes through in the red, that'll let us know from that time that jumps up on the board. We've got 2 hours that we have to have our field staff on the ground to that job. And so rather than us waiting for an email or a Teams message, it's in front of us, it's live. There's a number up there. We know how long we've got to get to it. So we can really start directing crews in the field of where we need them to go next as a priority level. We also have in there our minor works. So we have a first responder team. They go out, they'll have a look at jobs, they'll understand what it requires. We can then send that straight back to a crew that can go out there with just materials from a vehicle to repair, or whether it needs to go to planning for that, getting permits, big machinery, all those sorts of things. They're then supplying the planner with up-to-date information as well. Our defects, so anything that we find wrong in the field, asset-wise, we know that there's something wrong. We've got to process this, turn it into a work order, and get it back out to our crews to get this straight away. And we also have in the bottom right-hand corner, that's our application. So when someone puts in an application for a new house build, we can get water to that house supplied straight away as well.
As the issue lead, this is the kind of dashboard that I love to look at. All zeros, no work outstanding, and all work accounted for. Most days, this dashboard does not look like this, trust me.
No. Especially when we started, this one did not look great at all. We had to standardize that terminology, get that data in place. Now that we've got it in place, this is what our target is. And this is actually a live snapshot from this morning, so that we knew that we were on target to where we were. Our next one is the size of the elephant. So what does that actually mean? That's our actual workload that we have in front of us here at Logan Water at the moment. Again, this is live data that was taken, a snapshot from this morning. So what does it actually mean? So within our planning and our scheduling team, so this is where our planning and our scheduling dispatch sit at the moment. When we have a look at this, we know that we've got 476 water jobs, 247 wastewater jobs sitting within our realm that we know that we have something to do with. So in our planning system, in our planning roles at the moment, that's where all those jobs lie at the moment. So we know that when we have a look, where do we got to start giving our finer detail? Where do we really got to start pushing efforts to? Are there things that we can package up? Are there things that we really need to start focusing on? We can start getting sound decisions from our data from this. So this one just jumps in really quickly. That breakdown at 476 using the live data. You can see a large chunk of ours is in our hydrants, our fire hydrants. That's where the majority of our work sits. And we can start making decisions of going, should this be something that we can package up? Is there some sort of program that we can put together to really get these hydrants maintained? In our wastewater area, we've also got our large chunk is our sewer manholes. So our wastewater access chambers, that's where we know that we've got to start focusing our data, our field crews to start trying to bring these numbers down to manageable. So again, we're using our data that we have within our system. This one is our desired service of leaks, our DSL. This one tells us live as of this morning. This is our active leaks within our city. So when we have a look at this, this is our lost revenue. So we purchase our water from Sec Water. We put it through the network and then we let it go. So every one of these that's leaking is lost money to us. Not only that, it's also a loss of resource. So when we have a look, we can see now where we've got works and how old these are. So this is live data to say how old some of these are, and this is all done in working days. So when we first started tracking this, we were about 3 to 4 years behind of lost water. Our oldest one that we currently have is 146 days old within our scheduling, dispatch and field crew. We do have a couple that are older than that in our renewals program, and that is with assets that require a full tear down, repair and replace. So they're our bigger ones, but this gives us real-time data to show that we're focusing our areas in the right place. So we've jumped down 3 years since we've started this. The last one that we'll go through is our councillors. So our Logan City Council, our councillors that we have within. This one shows a quick breakdown. I'll just show you the first councillor. So in Division 1, which is our councillor Bradley, we can see that since we started collecting this data, we've done just under 7,000 jobs. Currently, we've still got 38 water jobs that are active in that area, in that division, and 75 wastewater. So this can start giving us real live data to start giving back to our councillor to say, look, this is where we know that each division's at. When we compare that to all of our divisions, we can start showing that we're not just focusing in one area, in one division, but we can also start showing what we're looking at. So our biggest thing at the moment is trying to get that lost revenue with our leaks data down. So these water jobs are what's coming down, but it also breaks down where across our city our efforts really are, and that we're not just focusing in one little area, where we're focusing across the lot.
Okay. The future, what's next? So we are looking at bringing wastewater treatment plants in. They are through SciTech. It's one of our 6 monthly targets. We've had a secondary mini-ish that's just gone live at Logan Home Depot. So now we have a backup control room. It's fully operational and it's ready to go if we ever get evacuated or if anything happens here at York Street. Collaborating with Origin and becoming the first Australian multi-scope agreement using renewable energy. So we are looking at having the ability to transfer energy from generators to mains power within the ish. This is a quite exciting project. We're looking at delivering at that at the end of 2026. And we're going to be running on effective and efficient, effective at the centre of operations-ish, making sure that we are the hub of everything here at Logan Water. We're keeping aligned with industry standards and just making sure that we keep learning as well. If there are any questions, guys, you do have the chat to pop them in. I will hand back over to Zolboo. Thank you so much, Zolboo.
Thank you so much. Such an impressive work, Tyron and Anna. Thanks for sharing about it. Yeah, thanks to everyone, Peter, Prevos, and also Anna and Tyron. Thank you for sharing about your experience with ISH, and also thanks to Peter for sharing his journey and on the data literacy and also like 4 of the main causes. I think it was very interesting. And for Tyron and Anna, I've just saw that some people have went over to Mentimeter, and I think about 5 organizations and people say they have a control room in their utility. So yeah, that's good to see. We had 2 questions, but we have a couple of questions received from Slava and David to 3 of you, but with the interest of time, what I will do is I will gather these questions and then have it offline from 3 of our speakers. And when I follow up with you all on the follow-up slides and also recording, I'll just have them posted on our website as a kind of all resources together. So with that being said, I just wanted to say thank you everyone who joined. Thanks for everyone who presented, sharing your experiences. I really appreciate all of your time. If you have any questions, anything you're interested, this is my contact details. Please feel free to reach out to us. And we are looking forward to seeing you in our upcoming webinars, or feel free to connect with me if there's any questions that you might have. And thank you so much for everyone who's joining. Have a great day ahead, and we'll see you later.